Thank you for joining us this afternoon for our talk. Today's presentation will illuminate how weather records contained in whaling ship logbooks can be used to assess shifting wind and weather patterns. Dr. Timothy Walker and Dr. Caroline Ummenhofer from Woods Hole Oceanographic Institution have researched logbooks spanning the period from 1790 to 1910 in several archives, including the New Bedford Whaling Museum, the Providence Public Library, Falmouth Historical Society, and of course, the NHA's archives. The logbooks contain systematic daily weather observations such as wind strength and direction, rainfall, and cloudiness. Their findings demonstrate that these ships' logbooks provide an important long-term context for changing weather patterns over the world's oceans. Timothy and Caroline will discuss challenges and opportunities for climate research through data rescue and digitization of historical ship logbooks. So a little background on our speakers today. Caroline Ummenhofer studied marine biology and physical oceanography from Bangor University, UK, and has a PhD in applied mathematics from the University of New South Wales, Australia. She joined Woods Hole Oceanographic Institution as faculty in 2012, and her research focuses on the ocean's role in extreme events such as droughts and floods, and their impact on human and natural systems. She has participated in art science collaborations at museum exhibits about marine heat waves and the oceanic water cycle. Dr. Timothy Walker graduated from Hiram College and received his PhD at Boston University. He is a professor of history at the University of Massachusetts Dartmouth and is a scholar of maritime history, colonial overseas expansion, and transoceanic slave trading. Walker is a guest investigator of the Woods Hole Oceanographic Institution, drawing climate data from archived whaling logbooks, Portuguese colonial, and other maritime documentation. In 2020, Walker was appointed by the governor of Massachusetts to serve on the schooner Ernestina Morrissey Advisory Board, where he is the chair of the Educational Programming Committee. So please join me in welcoming our two speakers today, Caroline and Timothy.
Thank you so much. It's really a great pleasure to be here. And in fact, when we began this project about 6 years ago, we spoke in this room right at the initial phase of our project. And so we're quite a ways further along now, and we're happy to share some of the things that we've been developing over the last 6 years and through COVID and through the turbulence of the last sort of 6 years in terms of the COVID pandemic. But that had big implications for our research, and some of those have actually turned out to be rather well. So what I want to do today is share with you about this project, which is an interesting project from a number of different standpoints, one of which is that it's really rare that you get people in the hard sciences working with people in the humanities. And so we have this sort of cross-disciplinary collaborative project that marries together research skills that you don't normally find together. And so for us, this is actually very exciting. So if I can figure this out, I want to remind us that we're looking at ships that are driven entirely by the wind and by currents. And so one of the things that makes this project so valuable is that we have really well-kept records going back about 250 years or so. And so one of the questions that might come to mind for you is, why are we using whaling logbooks? Well, one reason is that big collections of those whaling logbooks are right here in our backyard, including here at the Nantucket Historical Association, where we really started a lot of this work. But also science, for understanding climate science, you have to have long data sets, long records. And the whalers are in a position, because they wrote everything down day by day when they were at sea in their logbooks, they can provide us with the material that we need to create a very long record of weather in different parts of the world. The whalers went to really remote locations. They went to places like the very far South Atlantic and the far South Indian Ocean. They went to places where prior to the 1980s or so, we simply didn't have systematic data. And so we're able to fill in data that doesn't exist in any other way. And we also have these records that are extraordinarily well preserved in communities like Nantucket and New Bedford and other places where the whaling families kept their records, and they kept them, generally speaking, in very good condition. We have recorded about 15,000 whaling voyages from the 18th century to the early 20th century, and of those, we have logbooks for about 6,000 voyages, and of those 6,000, close to 4,500 are really easily accessible in 5 different libraries and archives, including where we are today. The New England whaling industry is probably the best documented industry in the early modern world. And because of the needs of things like maritime insurance and the idea that all vessels are supposed to keep a daily record of what they do at sea, we have great records from the various logbooks. And the peak of whaling, of course, is the 1840s to the early 1860s. New Bedford became the center of, I live in New Bedford, although I'm originally from the Midwest, but I moved out to New Bedford because of my interest in maritime history. And I came to Nantucket for the first time precisely because I wanted to look at the whaling logbooks that were kept here. So what can we get from whaling records? Well, the ship logbooks contain all kinds of invaluable meteorological data. We get our latitude and longitude, so we know the position of the ship and we know where the weather is happening. We get the wind direction, and we also get the wind force, the speed at which the wind is blowing. And the whalers are recording this usually 3 to 4 times a day, sometimes a little less if they're busy, but almost whenever the ship's watch changes, they are writing down the weather conditions at sea. We get information about precipitation, sometimes about temperature. They record when they endure a big storm, so we get weather variation, and occasionally we get information about currents. So all of this is really useful information that we can collect using archival research methods, and then put all of that into an online database and transfer it over to Woods Hole Oceanographic Institution, where it then undergoes various kinds of analysis. Now, the thing about whaling logbooks is no 2 of them are the same. They look really different, and they are as quirky and different as the log keepers themselves. There's no standard format for them, and so they can look quite different. This is one from the Abigail, which was a New Bedford whaler that visited the Indian Ocean, the Pacific Ocean, and the Atlantic Ocean. On each page, you have about 5 days worth of weather information and other things that are going on aboard the ship. But notice that the length of the voyage, this is pretty standard, 1831 to 1835. A typical whaling voyage would last usually around 3 years on average. 3 to 4 years was not uncommon. The longest whaling voyage on record was 11 years. And so you can imagine that being out to sea this long, they are keeping track of the weather for long periods of time. But keeping a logbook was a legal document. And it was a legal document that every ship had to keep. They would turn it over to the owners of the vessel when they got back from their voyage. And it was a way to record exactly what was going on board the ship at any given time. This is the reading room of our very own Nantucket Historical Association, and here we are several years ago starting research on some logbooks. Here's another logbook from the Nantucket Historical Association. So you can see it looks really different from the logbook that I showed before. Those little whale stamps, by the way, were recording when they make a sighting or a kill of a whale, But that, on average, that only happens 20 times in a voyage for average whaling ships. They're not taking huge numbers of whales on average. But we're not interested in the whales that they're taking. We're interested in the weather that they're recording day by day. By the middle of the 1600s, the middle of the 17th century, their sailing ships and navigators had pretty much established the most efficient ways to get from place to place. They had these maritime highways that are in dark blue on my map there. But the interesting thing about the whalers is that they don't stick to those maritime highways. They're following the whales, and the whales don't respect the maritime highways either. So the whalers are going to places that are some of the most obscure and most remote parts of the world's oceans, and they're recording weather data in those places. And that means that for us, the data that they collect is really, really valuable. Each dot on the map here represents a whale that has been taken. The red dots are sperm whales, and the blue dots are right whales and humpback whales. Now, just one extreme example. This is the one lone remaining whale ship. It's the Charles W. Morgan. It's in the Mystic Seaport Museum, where it is very well taken care of. Folks in New Bedford are a little bit salty about the fact that Mystic Seaport has the whaler that came from New Bedford. But as an extreme example, look where she went in her 80-year career as a whaler. She goes all over the world. And this gives you some sense of just how global the data is that we can collect for our project, gathering weather information from the whaling ships. Now, of course, we're taking information about latitude and longitude. We need to know where the ship is so that we know where the weather is happening. And this is taken using old 19th century methods, using a sextant to establish the latitude, and a ocean chronometer, a timepiece, a clock, to establish the longitude, the east-west position of the ship. But ships' clocks, of course, can get out of sync. They can gain time or lose time, and that has an impact on your navigation. So when ships would pass out on the ocean, they would often ask one another what their longitude position was, so they could double-check each other. They could use it as a check. And they actually had a flag hoist that meant, what is your longitude? And this comes from the 19th century, a ship called the Smyrna. Well, here's a scene from the Providence Public Library, where they have a very large collection of logbooks. And this is us gathering data. On the computer, you can just sort of see we have a purpose-built data collection website that our researchers use to input data from the logbooks as they read through them. And much of the work that we do now is digitized logbooks. So during the COVID lockdown, a lot of libraries digitized their logbooks and made them available online. So for our researchers, that makes it a little bit easier to get access to the data, because much of it is now on high-resolution digital images on something called the Internet Archive. And again, the things that we can take from these logbooks, this is our template for our data entry. We are recording the date and the time. Usually the ship records its noon position because that's when it's easiest to get a latitude reading using a sextant. They have the ship's position, the latitude, longitude, landmarks with range. If they're near an island or near a headland of some kind, they'll write that down, and that allows us to help locate where the vessel is. We get the wind direction and the wind force. The sea state, which coming across on the ferry over the last couple of days has been a major concern here in Nantucket. The weather and the water depth, sometimes they take soundings if they're close to land. Now, one of our issues is that these recordings are written down in qualitative language. They're descriptive terms. Things like the wind force would be described as a strong breeze or a near gale or a gentle breeze. And we have to translate that into something that is quantitative so that it can be then analyzed. So we're not the only researchers to have ever done this. There are other researchers that worked on other caches of maritime documentation. We're the first ones to systematically use the whaling records for this. But earlier researchers came up with a conversion table for the Beaufort wind force scale, which was formulated in the early 19th century. And so now we can figure out a way to translate that into knots or meters per second. And that's what we then do in the post archival stage where the data is being crunched and analyzed. To give you a sense of how many logbooks we're looking at, these are the top 5 archival repositories for where logbooks are. New Bedford Whaling Museum has about 2,500 logbooks. Nantucket has about 400, but Nantucket has some of the oldest ones, so going back to the 18th and very early 19th century. The Free Public Library in New Bedford has about 500 logbooks. Providence Public Library, curiously, has about 800 logbooks covering 1,000 voyages. Sometimes you get more than one voyage in a logbook. And all of those were digitized. So when COVID began, we immediately switched our attention to the collection at Providence because we didn't have to go into an archive to look at them. And finally, Mystic Seaport has about 250. We've also started using regional archives. So Falmouth Historical Society, for example, which only has about 40 logbooks, but they're really useful logbooks for us. So we've incorporated them into our project as well. How many have we worked through already? About 220 altogether. Not all of them are represented here, but we've got about 220 registered in our database. Some of those are still being actively collected, but we've finished about 210 of them. But that has generated over 131,000 days worth of data. So on average, we're getting about 500 to 600 days of data out of each logbook. And that's really useful for us. We're generating a kind of mosaic of weather data that we can use then to analyze how weather changes over time. Now, I want to just share with you that we have another division of this project, which is based in Lisbon, Portugal. You may have heard from my introduction that I am also a historian of the Portuguese world, and so I had good connections with maritime archives in Portugal, and we're using Portuguese Navy records going back to the mid-18th century as well. And the Portuguese, because of the nature of where their colonial holdings were, they can also fill in places where other national ships don't go. So places like Goa in India and Mozambique and Angola along the coast of Africa, they give us interesting data too. They're all held in this old 18th century rope works. This is a building that has these long wings where they were making rope. And when you go into the wings where they keep the documentation, it looks a lot like that last scene in Raiders of the Lost Ark, where they're hiding that crate full of that had what's it called? You know, the Ark of the Covenant was in it. It looks like that. There's so many pieces of information and bits of documentation that are packed into this building in Lisbon, Portugal. This is our team there doing research in the archives, and we are using data that goes up with the Portuguese right up until just before the Portuguese Revolution in 1974. So we're using logbooks up until the 1960s, and that brings a lot of the data right up to date. We have had good luck with people publishing about our project and getting our own research out. So we were very fortunate that Smithsonian Magazine did a story about our project last summer, and we published in the first edition of a new peer-reviewed journal from Mystic Seaport that came out also last year. And Caroline, my research colleague, who you're about to hear from, was the co-editor of this book about the Indian Ocean, and I contributed a chapter to this as well about the maritime history of the Indian Ocean. So I will, with that, say thank you so much, obrigado in Portuguese, and give you over to Caroline, who will tell you a little bit about the science analysis side of the work that we're doing. Thank you.
Welcome, everyone. I'm Caroline Ummenhofer. I'm an oceanographer and climate scientist. And before I start telling you about why I'm interested in this project and my role here, I'd like to give a shout out to the students and early career researchers that are named up there. They've been really instrumental. This is a very labor-intensive project, as you can imagine, and they've been really instrumental in helping with a lot of the data analysis. And it's been really great to also bring them into this project to really work on a very interdisciplinary study, as Tim mentioned, that brings together natural scientists and people from the humanities. So it's been a real boon to have them involved. As I said, I'm a climate scientist. I'm interested in the ocean's role in weather, climate, in particular extreme events, droughts, floods. The ocean plays a big role in that because most of the water on our planet is in the ocean. So whenever you're looking for rainfall on land, ultimately that water will have come from the ocean. So it makes, to me, perfect sense as an oceanographer to be interested in rainfall and the role that the ocean plays for that. Extreme events are rare by definition, and to understand something about the drought of the century or the 1 in 100-year flood event, we typically need very long records. And to track how these extreme events then affect water resources or agriculture on land and what the future might hold, very long records are really critical, and outside North America or Europe, those are really hard to come by. In particular, out over the oceans, we have very little information about what the weather or the ocean temperature conditions were like 200 years ago or something like that. And that is really where a lot of my research focuses on, trying to bring together lots of different data sources in trying to understand long-term context for our climate to know how things are changing currently. And as you can see from this schematic, since about the 1980s, we've got satellites. Satellites are great. They give us a global view of all the weather and environmental conditions that are going on. But they weren't invented until the 1980s. And as you go back further in time in this timeline, you can see that the data that we have, the observations we have, become sparser and sparser, and there might only be very few observational stations around the world by the 1920s or by 1900 that are recording weather conditions. And so a lot of my research really tries to extend this further back in time, and I use a variety of different tools and technologies. Numerical simulations, computer simulations of the ocean, the atmosphere, climate system overall is one tool. I also work a lot with experts that use tree rings, for example, to get at past drought variability. The tree will only grow very little in a year that it was either too cold, too hot, or it didn't have enough water. And then it will only put down a narrow ring. If everything's great, it will grow a lot, so a wider ring. And we can track past hydroclimate through that. I also work with people that go into caves to collect stalagmites, that also record if there's a lot of water dripping down, they might be growing a lot, and we can again measure that. For corals in the ocean, again, we'll put down similar rings as trees do, and you can X-ray them and get these growth bands that you see there on the right. And so we can use that to get back at ocean temperatures or the salinity, salt content in ocean water going back centuries. So really cool tools. And most recently, I've been working with Tim over the last 5-6 years to use historical records. And they are a wonderful thing because they gave us information on a really fine temporal scale. Tim talked about the whalers taking weather observations several times a day. That's way more than what we're getting out of a tree, where we might just be able to say, oh, this particular year was a dry year, or this particular year was a wet year. So really getting at the building blocks of weather and climate with these logbooks is really important. So Tim already mentioned what we are extracting from the logbooks. Here's just a reminder, date and time, ship positions, landmarks, wind direction, sea state. And you can see also in the right-hand image there that the whalers did have a lot of time on their hands. They were really elaborate drawings that they've made in the logbook. So as a natural scientist, I found that really fascinating, actually seeing all the intricate penmanship as well as the artwork that is entailed in the logbooks. So this is basically where we are up to right now. Tim mentioned over 100,000 daily weather entries, and it's almost hard to see, but every single little cross there is a recording where we have a latitude position, a longitude position, and what we call a usable wind condition, and I'll talk about that in a little while. And we've color-coded them by year. And so the darker colors are further back in time, and then the more recent colors are then going into the greens and yellows. And you can see really, again, the whalers traveled all over the world's oceans. We have really dense coverage in the North Atlantic, which makes sense because we're using New England whaling ships that all left out of New England ports. So no matter whether they went to the Pacific or the Southern Ocean or the far Indian Ocean, they would leave from New England, and we have tracks across the North Atlantic. Here we are looking at the distribution of the whaling records over time, where we have weather entries. And this tracks pretty well between the 1820s to the 1900s, with the heyday of the whaling in the 1840s to 1860s. So most of our records fall into that time period. And for some of those years, you can see we're getting up to 4,000 or in excess of 4,000 daily weather observations for a particular year, which is absolutely amazing, I think. They are not uniformly distributed, so here is basically the same information that I just showed you over time. Here we're looking at, again, all the different tracks, individual crosses for every weather observation, but now split into the different decades, going from the 1820s all the way to the 1890s. And again, you see most of our densest coverage is in the 1840s to 60s. Now, Tim already mentioned this. The whalers didn't carry instruments to measure the winds, and they were not recording this in nautical miles or meters per second or something that we can compare with modern observations, but they were really descriptive in their terminology and how they were describing the winds. And this is a very well-organized logbook that you see there on the left-hand side. But even there, the terminology was very descriptive. And on the right-hand side, I've given you just an overview of some of the terms. Tim made it sound really easy. Like, we have these terms. Here are the 13 different terms on the Beaufort scale. You just map it, and there's your meters per second. I can assure you it's actually not. So this is where a lot of the work of the student researchers comes in. Here I've just given you for the first 3 terms on the Beaufort scale, the 0, the 1, 2, and 3. It's amazing how many variations of light winds a whaler can actually put down. So these are all the uniques. You can see light airs and variable, light baffling airs, light baffling, light airs and very baffling. It's a lot. It's lots of different ways of saying light airs. And so a lot of work actually goes into mapping everything onto these terms. I'll spare you going through Beaufort 4 to 12. But once we do that, all that mapping, this is the distribution of winds that we get. So what is the wind force and how many counts do we have? And you can see that for the most part, the wind force falls between a 2 and a 6 that are most common. We have very few 3s, which apparently is not uncommon. Other research that uses other archival age of sail ships comes to similar conclusions. They don't often describe a 3. There's a lot of 4s to 6s on the Beaufort scale. Now, initially we started out thinking about wanting to study how major storms have been changing out over the oceans. Hurricanes, tropical cyclones. Have there been more? Have there been less? And one thing you notice on this scale is that there's nothing above a 10. So there's no 11 or 12, no hurricanes. Now, we need to be careful with the interpretation. We shouldn't take that to mean like 200 years ago there were no hurricanes. But we need to be, in particular at the upper end, need to be careful. First, these are rare events. Second, there might be survivorship bias, right? The ships that encounter those strongest storms might not have made it back, i.e. we don't have a logbook to actually record that. Or there's also behavioral bias. The whalers were pretty good in knowing the wind conditions, and so they avoided those areas at times of the year where it was more likely to encounter strong storms. For example, we have very few records over the subtropical North Atlantic during wintertime, which makes sense. If you're setting out of New England, you'd rather not go and leave New Bedford during wintertime to encounter strong storms. So there is certainly a bias, and we need to take that into account. But still, that data can still be very useful, and I'm going to show you how in a second. So one of the first things that we wanted to do is compare how do the weather observations that we get from the whalers, how do they compare with our limited observations that we have otherwise that are supplemented with numerical models, computer simulations during the 1800s. These tools are called reanalyses, and so we are comparing. Every dot here is a whaler that has observed a certain amount of wind speed, and we are then comparing that between the 1800s and to 1910 with the complementary data from our best estimate of modern instrumental data. And the box and whisker plot there basically shows you that we're doing pretty well. The whalers are, on average, often describe around a 4, and that is also with a bit of wiggle around it, 4 to 6, or between 2 and 4, with most of the entries being a 4, and we're seeing something similar in the reanalysis. So that gives us confidence that we're not doing too bad a job in actually our conversion to the Beaufort scale. But what can we do with this data? Well, for that, I'm going to give you a quick introduction, 101 global wind systems. So what we're looking at here is a map of the long-term global wind systems. And they're very, we can see certain features in all the ocean basins. For example, each ocean basin has a subtropical high pressure system. This is called, in the North Atlantic, the Bermuda High or Azores High. You might know this from the weather maps. All the other ocean basins similarly have such subtropical high pressure systems. Winds are very calm there, and they rotate around these high pressure systems. We can also see the easterly trade winds that, again, were very well known to during the Age of Sail. There were steady winds that were used by the sailors to traverse ocean basins. And we have strong westerly winds in the mid-latitudes. This is the storm tracks, and they are particularly prevalent in the southern hemisphere. So this massive belt of very strong westerlies that goes all the way around Antarctica. And these winds have actually been shifting. In the last 50, 60 years, they've been getting stronger and shifting further south. And it's really hard for us to put that into a context, into a long-term context, because as you can see, there's very few land masses in that whole light blue area. There's very few land masses, no instrumental data, no observations. It's just deserted ocean islands and very little land in those areas. Not very many ships would go there. Why would you want to spend time over the windy Southern Ocean? But the whalers did. And they actually spent quite a lot of time in that strong westerly wind belt. And so one thing that we can do, because it's this very strong wind belt all the way around Antarctica, we can basically lump together all the data in that strip around the Southern Ocean and look at how the winds are changing. And that is what we're doing here, again, using the modern data that I mentioned, the reanalysis. And you can think about this as basically looking at the westerly winds and how strong they are. So if the arrow is further to the right, it's stronger westerly. And so what we can see over time, because we've also color-coded in different years, as the earlier years again in the bluish, darker colors, and then the more recent years in the 2000s in yellow. What you can see there is that over time, those westerlies have been getting stronger, and they've been shifting further south, as I mentioned. And now we can compare over that same stretch, this band of strong westerly winds around Antarctica, we can compare and say, well, let's lump together all our observations that the whalers did 200 years ago. This is telling us something about the winds of the last 50, 60 years, how they've been changing. Where and when did the whalers see the strongest winds? And this is what you can see there. And we've split this into two periods, an earlier period prior to 1850 and then one after 1850 in yellow. And the second period, you again see that after 1850, it was a lot stronger and more southerly compared to the earlier period. And so that really tells us that the whalers are really helpful in putting this strong westerly wind shift that we are experiencing in modern times into a long-term context. We can see the whalers knew these as the Roaring Forties, this belt around Antarctica. And meanwhile, because it shifted so much further south, it probably should be more called the Furious 50s. Now, you might say, well, who cares where and the strong westerly wind belt around Antarctica goes? It actually does matter because rain-bearing weather systems travel on these westerlies. And Southern Africa, South America, and Southern Australia, they receive their rainfall on these rain-bearing weather systems. And as that entire belt of westerly winds has shifted further south, the rain-bearing weather systems have also shifted further south. And they have left Southern Africa, Southern Australia high and dry. And that's really what's been happening. Cape Town a few years ago had the worst drought on record in the 113 years that they've had records. And so that really proves or shows how important knowing about those winds out over the ocean, very far from land, how important they are because they bring rainfall to land. And so shifts in these weather and wind patterns can really be important to understand them and to put them into a long-term context. Now, I'm really interested in those weather patterns that are associated with rainfall. And this is pretty novel work. It's still in a kind of proof of concept phase. But I was pretty skeptical whether we could tell something. So the wind, I think, is one thing. The whalers were very systematic in how they were recording that. I was skeptical whether we would get usable data out of the rainfall descriptions. With the winds, they followed the terms in the Beaufort scale. With rainfall, you might hear or read something like, oh, it's rained as we've never seen it before. That's hard to put into context, as this person has not seen it in this spot. Are they from a dry place? Are they from a wet place? Really hard to tell, right? What are we to make of that? So I was skeptical whether we would get anything useful out of that. So here, just for comparison, is what our modern satellites tell us the rainfall distribution is out over the oceans or over the whole world. Blue areas are pretty dry, red areas are pretty wet, unintuitive color scale, but there you have it. I've highlighted some of those boxes, which are areas where we would expect relatively little rainfall. And you can see in the red dots there that we also get relatively few whaling records talking about rainfall. If you compare it to when they talk about clear conditions, they talk about in those boxes where we typically expect clear conditions and very little rainfall, we get way more indications that they are talking about clear than they are talking about rainfall. So that seems to indicate that just by splitting between clear and rainfall, and if we are investigating this a little bit further, we might get at useful information also about rainfall, which I find really pleasing. Now, thinking about this more long term, this reanalysis effort has been going on over a decade or so. International community efforts to bring together all the observations and all our best estimates of what winds, weather conditions are like around the world, feeding that into giant atmospheric models, similar to the atmospheric models that produce your weather forecast. But here we're actually looking back in time, not forward. And so what we are doing here is actually in the center of the animation here is Antarctica. And we're looking down onto Antarctica, and there's this belt of very strong westerly winds running around Antarctica. And this is during the Antarctic expedition, the British Antarctic expedition during 1910 to 1912. Very few observations at that time. And so the computer model helps us generate what the weather conditions look like, and it can do so by all these yellow dots. Each of those yellow dots is a ship-based observation where a whaler, a research ship, a trade ship, a merchant ship, navy ship was out there and was recording weather conditions, and that has been fed into the atmospheric model. And so what you can see here is that each yellow dot helps us understand what weather conditions were like, and the people in the UK that have, at the Met Office, that have developed this animation, they dub this as the ship logbooks help us lift the fog of ignorance. All those gray areas, we have absolutely no clue what weather conditions are like, but wherever we have one of those yellow bright spots, that's actually shedding light on what oceanic and atmospheric conditions were like. And so in due time, we are hoping that our efforts will feed into efforts like this as well. Jocelyn already mentioned art-science collaborations in her introduction. It's been something that I've been fortunate to engage with artist Deb Aarons, who's based in Dartmouth. And she's done these wonderful kinetic sculptures of marine heat waves that are inspired by eddies spinning off the Gulf Stream, bringing warm waters onto the shelf. And marine heat waves, so extremes in the ocean, can happen, and they've happened very frequently over the last decade or so, and they're affecting a lot of the marine life, fisheries, and the economies that depend on that. And so one thing that Deb was really intrigued by is putting side by side some of our modern tools, like computer simulations, the data we generate, the satellite data, and so on, with the data that we're generating from the whaling logbooks. And so those are kind of interwoven there. There's a lot of marine critters that are being affected by marine heat waves, a lot of data and tools that we are using to study them. And they've been a really great tool, both to go to conferences, for public engagement. They've even been, if you have been in Falmouth last winter, you might have been sipping coffee with the marine heat waves. So it's been a really wonderful tool to actually engage and have different conversations around extreme events and how they are affecting our ecosystems. So with that, I'd like to conclude. There are thousands of New England whaling ship logbooks that provide valuable weather information. They're pre-instrumental, but we've shown that we can quantify those and actually compare with modern data. And one of the first things that we've seen is that poleward shift of the westerlies around Antarctica, moving from roaring 40s, as the whalers knew them, to furious 50s. So that's been really exciting. I should also acknowledge and give a big shout out to Helen Gordon at HUI and the IT team, who's been the technical support and has done a lot of the development of this custom-built database. And we've also been really fortunate about past support for this project. So where to next? Well, we want to also look at changes in other wind systems around the globe. The monsoons, the easterly trade winds, other areas. I've already mentioned the water cycle. And we are also thinking about potential citizen science projects where it's not just archival researchers that are helping us generate data, but there would be a citizen science where anyone, all of you, could be helping us to generate new data. It's a unique project. It hasn't been without challenges because it falls between science and humanities. That is I think, one of the exciting aspects. It's one of the strengths. But in particular with funding, that has been a real challenge. For the natural sciences, this is way too historic. For the humanities, it's way too scientific. So that has certainly been a challenge. And the changing funding environment, I'm sure you're all aware, isn't really helping in that regard. So that's been some of the challenges that we've been encountering with this project. If you want to learn more, there are postcards. There's a QR code, and with that, thank you very much for your attention and happy to take questions.
We're very happy to take questions as well, so.
Oh, sorry. Oh, I didn't realize. Sorry, there's one question I'd like to ask you about one of your maps earlier on, where you showed all the whaling spots in the North Atlantic.
Yes.
Back a little ways.
Are you going to ask why there aren't any Arctic?
The blue dots. I notice a lot of absence around Newfoundland and at the upper part of the North Atlantic. Is that because at the same time there was the massive cod fishing that they came here, and perhaps the whalers didn't go up to interfere with the Grand Banks and the cod fishing from there?
So this was a choice on our part about which logbooks to focus on first. So we've excluded the Arctic and the far northern North Atlantic from the logbooks that we are mostly focusing on, because there have been companion efforts previously that looked at Arctic conditions and whether whalers encountered sea ice or not. So that's one other aspect where historic documents have been really useful in tracking sea ice extent. And there might also be some seasonality to it that the whalers were trying to avoid, at least during wintertime, those more northern areas. But this is part of our choice in what logbooks. So we've gone through 200 so far, 6,000 are there in total. We've got plenty more to do. We've made some choices in what to focus on first. And the Arctic and far North Atlantic was one of the areas that we haven't looked at as much.
If I could just add, too, there are other populations of whalers that went into the Atlantic Arctic. So whalers out of Dundee in Scotland went north, and so did Dutch whalers. They were whaling in the Arctic. The Nantucket and New Bedford whalers tended to go more to the south, and then later, right at the end of whaling, they started focusing on Arctic whaling between Russia and Alaska, so they would go up that way too. But our particular group of whalers doesn't spend a lot of time in the North Atlantic Arctic.
Thank you. Thank you very much.
Hello. Obviously, data integrity is really important. And one of the things that struck me when you were looking at light wind, that sort of thing, in addition to converting it to a more systematic way, did light wind to one group mean the same thing as light wind to another group? But I've got a series of questions with that. So as part of that, who was responsible for logging this information, and was the information corroborated by other people on the ship? I'm just really curious about the accuracy of the data and such.
I'm glad you're asking that, and no, I did not plant that question, but we are doing validation among different ships, and that goes back to what Tim was referring earlier. The whalers, if they were in the vicinity, they would exchange information or so. They would double check with each other their location, and so they also, whenever we are in the logbooks encountering that they met another ship, we are logging that information, because this allows us to actually cross-check. Did Captain A or did the record keeper of ship A and ship B, if they were in the vicinity, did they both talk about the same weather of that day? And that is what we are seeing here, is that we are for the most part within 1 or 2, and we've now got about 200 instances where we can put 2 ships together in the same vicinity, and they are typically between plus or minus 1 on the Beaufort scale. So that is certainly something that we are checking. And that is really what is also happening on the WHOI side. After Tim and the researchers enter the data into the custom-built database, there's a very extensive quality control that double checks first the locations. Do they all make sense from one day to the next? Could they have traveled this type of distance? Do we get a location that might be over land? Those are thrown out. And we're very much erring on the side of caution that if data entry looks dubious or we're not entirely sure, is a clerical error, might the record keeper have been off, they are going to be discarded. And that is really getting at, when I said we have over 100,000 daily entries, but what we are calling usable wind entries, there's a considerable reduction, because there's a couple thousand that we are throwing out because the records seem dubious, or we can't make sense of them, or can't assign it a particular wind value. So we are being very careful about that, but that's a great point, yeah.
Further to that, I would say that in terms of consistency of vocabulary, the whalers are all trained up in a relatively tight professional group in which language had to mean something. When 2 captains got together and they were describing the conditions that they were sailing under on the other side of the world, they might be sitting around a fire in a chandlery shop in New Bedford, but they have to use language that actually means something. And so there's remarkable consistency among the way the wind conditions are described. And people who are trained up in that environment also begin to take on that vocabulary and can identify wind conditions. So is it perfect? No. And we know it's not perfect, but it's remarkably consistent. And so we're pretty comfortable with the amount of accuracy that we're getting. Other questions? All right, well, this has been a great pleasure. Thank you so much for your attention. And if you have questions, our contacts, I think, have been given out, but I'm at the University of Massachusetts Dartmouth. Caroline is at Woods Hole Oceanographic, and we're really happy to receive any comments or questions you might have by email as well. Thank you.